Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on convolution sum. It's also called as linear convolution. The convolution sum relates the input, output and unit sample response of discrete time systems. Linear convolution is very powerful technique used for analysis of linear time invariant system. X of n can be expressed as sum of weighted impulses, that is nothing but y of n is equal to x of n into h of n. The behavior of the LTE system is completely represented by unit sample response h of n. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. It is the linear convolution of x of n and h of n gives y of n. X of n is applied to linear time invariant discrete time system which can produces the output as y of n. This is the representation of convolution. The input sequence x of n can be given. Input sequence 1 also be given. The convolution sequence is nothing but x of n into input sequence x of n into x1 of n. Therefore, we can multiply, we can get the values as 2 into by using either by using tabulation method or multiplication method, we can get the representation of convolution. Therefore, this is the representation. Representation x of n is given as 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is nothing but x of n, x1 of n. 1 into 1, 1 into 2, 1 into 3, 1 into 4, 1 into 5, 1 into 6. When multiplied with 2, all these values, 3 multiplied, 4 multiplication, 5 into 1, 2, 3, 4, 5, 6 and 6 into 1, 2, 3, 4. We can get it as diagonal. We can add all these part. We can get it as your y of n is equal to 1, 4, 10, 20, 35, 56, 70, 76, 73, 60, 36. This is the representation of previous diagram. When 0 means 0, 2 means we can get it as your value as your 4, 3 means 10, 4 means 20, 5, 35, 56, 70, 76, 73 and finally x of 11 is equal to 36. 4 methods available to compute convolution sum: definition method, graphical method, tabulation method and multiplication method. These are the 4 methods to compute convolution sum. 4 steps involved in computing convolution sum: folding, shifting, multiplication and summation. Let capital M be the total number of samples of x of n and capital N be the total number of samples of y of n. Then the total number of samples in y of n be the m plus n minus 1. This is the convolution sum sequence. Input sequence can also be given. Impulse sequence, either by using tabulation or multiplication method, we can getting as your output as linear convoluted sequence. In terms of circular convolution, we can also get the circular convoluted sequence. Next one, find the convolution sum of x of n is equal to 1, 1, 1, 2, 1, 1, h of n is equal to 1, 1, 2, 1. By using multiplication method and multiply and added all these values, we can get y of n is equal to 1, 2, 4, 6, 7, 5, 3, 1. Properties of convolution sum. It can be classified into 3 properties: commutative property, associative property and distributive property. A commutative, y of n is equal to x of n into h of n. X of n multiplied with h of n, which produces output as y of n. Next one, associative property: x of n multiplied with h1 of n, again multiplied with h2 of n. Therefore, x of n multiplied with h1 of n into h2 of n. Left hand side sequence: x of n multiplied with h1 of n, again multiplied with h2 of n, which produces output as y of n. X of n multiplied with h1 of n into h2 of n, which produces output as y of n. Distributive property: x of n multiplied with h1 of n plus x of n multiplied with h2 of n, x of n multiplied with h1 of n plus h2 of n, x of n multiplied with h1 of n, again multiplied with h2 of n, added these two signals which can produce output as y of n. X of n multiplied with h1 of n plus h2 of n, which produce output as y of n. input output transference. When x of n, when linear change, we can get x dash of n multiplied with h of n, which can produce output as y of n. X dash of n multiplied with h of n, which produce output as y dash of n. This is the graphical representation. X of k, h of k can be given. H of minus k means is the folded signal of h of k. H of 1 minus k means it can be shifted by one step sequence. 2 minus k means shifted by 2 step. Minus 1 minus k means it can be h of minus k can be shifted by one sequence. Then when we can produce the output as y of n. That is nothing but h of 1 minus k, 1 minus k, 2 minus k. Therefore, h of minus 1 minus k. We can get the graphical representation of linear convolution sequence. Find the convolution sum of the given sequence. X of n is equal to 1, 2, 3, 4, 5. H of n is equal to 6, 7, 8. We can multiply and all the 8 5s are 40, 8 4s are 32, 8 3s are 24, 8 2s are 16, 8 1s are 8. Again multiplied with 7, 7 5s are 35, 7 4s are 28, 7 3s are 21, 7 2s are 14, 7 1s are 7. Then 6 added multiplied with 6 table, 6 5s are 30, 6 4s are 24, 6 3s are 18, 6 2s are 12, 6 1s are 6. Now we can add all these values. We can get the output sequence. Y of n is equal to 6, 19, 40, 61, 82, 67, 40. Next one, tabulation method. Same method. X of n is equal to 1, 2, 3, 4, 5. H of n is equal to 6, 7, 8. Now we can multiply it with all these values. We can get the result as y of n is equal to 6, 19, 40, 61, 82, 67, 40. Now by using definition method, totally how many values x of n is equal to? There is no index value. We can take x of 0 is equal to x of 4 is equal to 5, h of 0 to h of 2. Therefore, m is equal to 5, n is equal to 3. Total number of samples is m plus n minus 1. Therefore, 5 plus 3 minus 1 is totally 7 samples. N varies from 0 to 6. Y of n is equal to summation k is equal to 0 to 4 x of k into h of n minus k. Substitute n is equal to 0, where minus k means y of 0 is equal to 6. N is equal to 1, summation k is equal to 0 to 4 x of k into h of 1 minus k. Instead of k, we can substitute 0 to 4. We can get y of 1 is equal to 19. Similarly, for all the values 0 to 6, we can get totally here 7 samples. Y of n is equal to 6, 19, 40, 61, 82, 67, 40. This is your definition method. Next one, define convolution sum. Convolution sum can be defined as y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Total number of samples in y of n will be m plus n minus 1. M be the total number of samples of x of n, n be the total number of samples of h of n, y of n is equal to m plus n minus 1. List the methods involved to compute convolution sum. Definition method, graphical method, tabulation method, multiplication method. Y of n is equal to x of n into h of n is defined as commutative property. Mention the steps involved to compute linear convolution: folding, shifting, multiplication and summation. List the properties of convolution sum: commutative property, associative property and distributive property. Thank you.